Alright, second test. This is a simple set reset flip-flop. Here's the basic layout. Set input goes here, clear goes here, and it's sent into the K input of this. Cell 01 is a simple recirculate. It takes whatever's coming in from the left, sends it back, and also echoes it to the Q output on top. Set flip-flop side is where all the action happens. If we're receiving an input from the left that's at least 48, we take that as a set action and we put a 32 out onto, if we get a left that's 32, we send a 48 out to the right, actually 63 to set it. If we get a left input that's less than 32, we send a 0 out to the right. Otherwise, we take whatever's coming in on the left and we send it back out to the right. The feedback loop actually processes the input data. If it's at least 32, it'll send out a solid 63, otherwise a 0. And we're doing this with some nice macros now that just let us specify the output value by using this set TT macro. So, after that crystal clear discussion, here's the output of the circuit. We have two potentiometers. This one will be set, this one will be reset. If we turn the set input up, the output goes high, and we can bring the set input down now and it retains that high value. If we bring up the reset input and we exceed the 50% threshold, the output drops down, and now it's preserved even though we return the reset output back to 0. That in itself is not terribly inspiring, because that's basically how a digital set reset flip-flop would work. It would take a threshold, and if the input was above or below the threshold, they would interpret it as a logic 1 or 0. So let's make it a little more interesting and make an analog data flip-flop.